Mole concept. Introduction. Atomic mass is the mass of an atom expressed in AMU. The atomic mass unit is a very tiny unit of mass appropriate to the scale of single atoms. The concept of gram atomic mass gradually developed to express the atomic mass in grams. One atom of carbon weighs 12 AMU. 1 gram atomic mass of carbon weighs 12 gram. Gram atomic mass was termed as mole atom. 1 molecule of water weighs 18 AMU. 1 gram molecular mass of water weighs 18 gram. Gram molecular mass was termed as mole. What is mole? Certain quantity of substance. 1 mole of different substances, mercury oxide, sucrose, sulfur, copper 2 sulfate pentahydrate and sodium chloride and copper are shown in the diagram. 1 dozen egg is equal to 12 eggs. Mole is the same kind of unit as the dozen, certain number of things, but this number is quite huge, 6.022 into 10 to the power 23. 1 mole of sugar is equal to 6.022 into 10 to the power 23 sugar molecules. 1 mole of water is equal to 6.022 into 10 to the power 23 water molecules. 1 mole of NO2 is equal to 6.022 into 10 to the power 23 NO2 molecules. 1 mole of any substance is equal to 6.022 into 10 to the power 23 molecules of the substance. 1 mole atom of an element is equal to 6.022 into 10 to the power 23 atoms of the element. 1 mole of different elements are shown in the diagram as following. Mass of 1 mole atom. Atomic mass is the mass of 1 atom of element. Gram atomic mass GAM is mass of 1 mole atom of the element. Mass of 1 mole. Molecular mass is mass of 1 molecule of the substance. Gram molecular mass GMM is mass of 1 mole of the substance. Mass of 1 mole of gases. Relative molecular mass of oxygen is equal to 32. Mass of 1 mole of oxygen is equal to 32 gram. Relative molecular mass of hydrogen is equal to 2. Mass of 1 mole of hydrogen is equal to 2 gram. Relative molecular mass of carbon dioxide is equal to 44. Mass of 1 mole of carbon dioxide is equal to 44 gram. Relative molecular mass of sulfur dioxide is equal to 64. Mass of 1 mole of sulfur dioxide is equal to 64 gram. Relative molecular mass of ammonia is equal to 17. Mass of 1 mole of ammonia is equal to 17 gram. Mass of 1 mole atom of elements. Relative atomic mass of oxygen is equal to 16. Mass of 1 mole atom of oxygen is equal to 16 gram. Relative atomic mass of carbon is equal to 12. Mass of 1 mole atom of carbon is equal to 12 gram. Relative atomic mass of sodium is equal to 23. Mass of 1 mole atom of sodium is equal to 23 gram. Relative atomic mass of sulfur is equal to 32. Mass of 1 mole atom of sulfur is equal to 32 gram. Relative atomic mass of hydrogen is equal to 1. Mass of 1 mole atom of hydrogen is equal to 1 gram. 1 mole is equal to 1 gram molecular mass. Molar mass is equal to mass of 1 mole equal to relative molecular mass in gram. In the diagram, different balloons of hydrogen, nitrogen and oxygen are shown. The balloons all have the same volume. This means they all contain the same number of molecules. This concept was given by Emilio Avogadro. Avogadro's law: equal volume of all gases at same temperature and pressure have equal number of molecules. Volume of 1 mole of any gas STP is 22.4 liter. Volume of 1 mole is known as molar volume. Concept of mole: 22.4 liter at STP in terms of volume for gas 1 mole. In terms of particle 6.022 into 10 to the power 23 molecules, and in terms of mass equal to 1 gram molecular mass. Number of moles is equal to mass upon gram molecular mass equal to volume upon 22.4 equal to number of molecules upon 6.02 into 10 to the power 23. Calculate the mass of 5.6 liter of SO2 at STP. In the given question, mass upon gram molecular mass of sulfur dioxide equates to volume divided by 22.4. Mass is unknown divided by gram molecular mass of sulfur dioxide, which is equal to 64, is equated with volume, which is given in the question as 5.6 divided by 22.4. On cross multiplication, mass of 5.6 liter of SO2 at STP is equal to 16 gram. 5.6 liter of gas X at STP has mass of 28 gram. Find relative molecular mass of gas. In the given question, the applied formula is mass divided by gram molecular mass of X equated with volume divided by 22.4. Mass in the question is given as 28, gram molecular mass is unknown, is equated with volume, which is 5.6 according to question, divided by 22.4. Gram molecular mass of gas X is equal to 22.4 into 28 divided by 5.6 according to rules of cross multiplication, which gives 112 gram. Relative molecular mass of gas X is 112. Find number of moles in 3.01 in 10 to the power 24 molecules of NH3. The number of moles is equal to number of molecules divided by 6.02 into 10 to the power 23. In the question, number of moles is unknown. That is equal to number of molecules according to question, which is 3.01 into 10 to the power 23 divided by 6.02 into 10 to the power 23. On division, we get 5. Hence, number of moles of NH3 present is 5. Gay-Lussac's law of combining volumes and vapor density. Gay-Lussac's law of combining volume. When gases react, they do so in volumes that bear a simple whole number ratio to one another and to the volume of the gaseous product, provided all gases are measured at same temperature and pressure. The ratio between the volumes of the reactant gases and the gaseous product can be expressed in simple whole numbers. When gas A reacts with gas B to produce gas C at same temperature and pressure, then according to Gay-Lussac's law, volume of A ratio volume of B ratio volume of C is equal to X ratio Y ratio Z, where X, Y and Z are simple whole numbers. 2H2 reacts with O2 to produce 2H2O. 2 volumes of H2 is reacting with 1 volume of O2 to produce 2 volume of 2H2O. According to Gay-Lussac's law, volume of hydrogen ratio volume of oxygen ratio volume of steam or water is equal to 2 ratio 1 ratio 2. What volume of H2 is required for 20 liter of N2 to form NH3 at same temperature and pressure? According to question, the equation of the given question can be formulated as N2 plus 3H2 producing 2NH3. According to Gay-Lussac's law, volume of N2 ratio volume of H2 ratio volume of NH3 is equal to 1 ratio 3 ratio 3. The given volume of N2 is 20 liter according to question. Therefore, in place of 1 we can write 20. Ratio volume of H2 can be written as 3 into 20, and similarly volume of NH3 can be written as 2 into 20. Therefore, 60 liter hydrogen is required for 20 liter nitrogen. If all volumes are measured at the same temperature and pressure, calculate volume of NH3 required to give 150 cm3 of steam. 4NH3 plus 3O2 produces 4NO plus 6H2O. According to Gay-Lussac's law, volume of steam ratio volume of ammonia is equal to 6:4 according to the equation given above. Because 4NH3 is producing 6H2O, therefore the equation becomes 6:4. Now according to question, 150 centimeter cube of steam is produced, so volume of the steam can be deduced as 150. Now to get volume of NH3, we know that 6 volume of steam is giving 150 volume of steam. Therefore, 1 volume of steam will give 150 divided by 6 volume of steam. So, 4 volume of NH3 will give 4 into 150 divided by 6 volume of NH3. Hence, volume of NH3 can be written as 4 into 150 divided by 6, which is equal to volume of steam ratio volume of NH3 equal to 150 ratio 100. 100 centimeter cube of ammonia is required to give 150 centimeter cube of steam. 67.2 liter of hydrogen and 44.8 liter of nitrogen are taken to form NH3. Calculate the volume of the resulting mixture. N2 reacts with 3H2 producing 2NH3. Volume of H2 ratio volume of N2 ratio volume of NH3 is equal to 3:1:2 according to the equation given below. Now 3 into 67.2 divided by 3 ratio 1 into 67.2 divided by 3 ratio 2 into 67.2 divided by 3 is equal to 67.2 ratio 22.4 ratio 44.8. In the given ratio, 67.2 is multiplied because in the question it has been given that 67.2 liter of hydrogen is reacting with 44.8 liter of nitrogen. 67.2 liter of hydrogen reacts with 22.4 liter of nitrogen to form 44.8 liter of NH3. Volume of resulting mixture is equal to 44.8 liter NH3 and 22.4 liter unreacted nitrogen. Vapor density Vd, relative molecular mass, is equal to 2 into vapor density. Vapor density, ratio of mass of a particular volume of gas to the mass of an equal volume of hydrogen under identical conditions of temperature and pressure. Mass of certain volume of gas divided by mass of same volume of water at same temperature and pressure is equal to relative molecular mass of gas divided by relative molecular mass of hydrogen is equal to relative molecular mass of gas divided by 2, because relative molecular mass of hydrogen is equal to 2. Gas X kept in a cylinder has the mass of 10 gram, when hydrogen gas kept in the same cylinder at the same temperature and pressure has the mass of 2 gram. Calculate relative molecular mass of gas X. Vapor density is equal to mass of certain volume of gas divided by mass of same volume of H2 at same temperature and pressure. Vapor density of gas X is equal to 10 divided by 2, because in the question mass of gas X has been given as 10 grams, which is equal to 5. Relative molecular mass is equal to 2 into vapor density. Relative molecular mass of gas X is equal to 10. Empirical and molecular formula. Chemical formula. Chemical formula has been divided into empirical formula, which is number of atoms in simplest whole number ratio. Example, CH3, CH2O, CH2O. Molecular formula, actual number of atoms. Example, C2H6, CH3COOH, C6H12O6. Empirical formula from percent composition. Steps to find out empirical formula. Step 1. Divide given percent with respective relative atomic mass. Step 2. Divide each term by the smallest number. Step 3. If whole number ratio is not obtained, multiply with 2. A compound consists of 72.2% of Mg and 27.8% of nitrogen by mass. Find out empirical formula. Step 1. Divide given percent with respective relative atomic mass. Mg atoms ratio nitrogen atoms, which is equal to 72.2 as given in the question, divided by 24, which is relative atomic mass of Mg, ratio nitrogen atom, which is given in question as 27.8, divided by 14, which is relative atomic mass of nitrogen, which is equal to 3 ratio 1.98. Step 2. Divide each term by the smallest number, which is equal to 3 divided by 1.98 ratio 1.98 divided by 1.98, which is equal to 1.5 ratio 1. Step 3. If whole number is not obtained, multiply with 2. 1.5 multiplied by 2 ratio 1 multiplied by 2 is equal to 3 ratio 2. Empirical formula of the given compound is Mg3N2. Molecular formula from empirical formula when relative molecular mass is known. If molecular mass is equal to empirical formula mass, molecular formula is equal to empirical formula. If relative molecular mass is greater than empirical formula mass, molecular formula has n times greater number of atoms than empirical formula. Molecular formula is equal to empirical formula n. N is equal to molecular mass divided by empirical formula mass. Percent composition 75.95% C, 17.72% nitrogen and 6.33% hydrogen by mass. Relative molecular weight 240. Find the molecular formula. Carbon atom ratio nitrogen atom ratio hydrogen atom as given in the question is 75.95 ratio of carbon atom is divided by 12, which is equal to atomic mass of carbon atom ratio nitrogen atom, which is 17.72 according to question, divided by 14, which is molecular mass of nitrogen atom ratio 6.33, which is the percentage of hydrogen atom as given in the question, divided by 1, which is the molecular mass of hydrogen atom, equal to 6.33 ratio 1.26 ratio 6.33. Now the given ratio is divided by the smallest number, which is equal to 6.33 divided by 1.26, which is the smallest number of the three ratios obtained, ratio 1.26 divided by 1.26 ratio 6.33 divided by 1.26, which is equal to 5 ratio 1 ratio 5. Empirical formula of the given compound is 5 ratio of carbon, 1 ratio of nitrogen and 5 ratio of hydrogen, which is equal to C5N1H5. Empirical formula mass is equal to 12 is multiplied by 5 because 12 is the mass number of carbon and 5 is the ratio obtained on empirical formula, plus 14 into 1. 14 is multiplied because 14 is the mass number of nitrogen atom and ratio of nitrogen atom in our empirical formula obtained is 1, plus 5 into 1. 5 ratios of hydrogen is obtained in the molecular formula, which is multiplied by its molecular mass, which brings our empirical formula mass as 12 into 5 plus 14 plus 5 into 1, which is equal to 79. Now, to obtain N, molecular mass is divided by empirical formula mass. The molecular mass obtained according to question is 240 and the empirical formula mass we have calculated as 79. Therefore, 240 divided by 79 brings N value to 3. Therefore, molecular formula becomes C5NH5 multiplied by 3, which is equal to C15 N3 and H15. Calculations based on chemical equation. What weight of Cu will be formed when 47 gram of CuNO3 whole twice decompose Relative molecular mass of CuNO3 whole twice is equal to 188 and CuO is 80. The given equation for the following question will be 2CuNO3 whole twice decomposes producing 2CuO, 4NO2 plus O2. The ratio of the moles of CuNO3 whole twice, CuO, NO2 and O2 are 2:4:1. Number of moles in 47 gram CuNO3 whole twice are weight of CuNO3 whole twice divided by its mass number. The weight given in the question is 47 grams divided by mass number of CuNO3 whole twice, which given in the question is 188. So on dividing 47 by 188, 0.25 moles are obtained. Now, according to question, the ratio of CuNO3 whole twice and CuO is 2:2, that is equal to 1:1. Therefore, 0.25 moles CuNO3 whole twice will form 0.25 moles of CuO because they react in equal proportion. Mass of 0.25 mole of CuO is equal to 0.25 into 80, which is the molecular mass of CuO, that is equal to 20 gram. Balanced chemical equation gives the number of moles of reactant and product. Convert given mass divided by volume to moles. Find the required number of moles of reactant and product. Convert the number of moles to mass by volume. What volume of H2S at STP will burn in oxygen to yield 12.8 gram SO2? According to question, 2H2S plus 3O2 gives 2H2O plus 2SO2. Relative molecular mass of SO2 is equal to 64. 2H2S plus 3O2 produces 2H2O and 2SO2. H2S and SO2 reacts in a ratio of 2:2. Number of moles in 12.8 gram SO2 will be equal to weight of SO2 upon molecular mass of SO2, which according to question is 12.8 divided by 64 equal to 0.2 mole. According to equation, to yield 2 mole of SO2, 2 mole of H2S needed. To yield 0.2 mole of SO2, 0.2 mole H2S needed. Volume of 0.2 mole H2S is equal to 0.2 into 22.4 equal to 4.48 liter at STP. 4.48 liter of H2S at STP will burn in oxygen to yield 12.8 gram SO2.